In this video I'm going to produce a part in Edgecam, a simple turn part, but first of all I'm going to create a model from it in EWS and also in Part Modeler. So let's start by opening EWS, and this is the screen you're faced with. Just pick a line to start drawing and you can immediately start drawing in this area. You can see the length of the line as you're going, but what I tend to do is just draw the part as a sketch initially and then just add your dimensions afterwards, and that way seems easier and quicker to me. So then we just click on dimension, dead easy to dimension, and what you can do again, you can dimension it all over, and then just when you've dimensioned it all over, you can jump in and just alter them all. So I'm okay in these as I'm doing them, even though I ain't even looking at what they are. But it's quite easy then afterwards to just modify them up to the correct size. Dimension again, meant to do that one there and there. So now we've got some dimensions on there. You can neaten this up at any time, stick them wherever you think they ought to be. I mean, really, I think they should be on that side. If I just close that, you can dead easy move these around. Just do that. Just click on it, hold down your left mouse button, and you can drag it over to wherever you want, just to neaten it up. It's always good, because if you've got a mess on your screen, you can't really tell what on earth's going on. So just going to neaten these up a bit. So that's meant to be 120. 60, these are actually what I want them to be, 20, 40. And then when I want to create this into a turn part, I want to revolve it. So I click this revolve, immediately twists it round like that. And it wants an axis. You just click on your axis and you OK that. Now you have it, your model. You can add all other stuff to this. You can add your chamfers and your rads. So if we look at chamfer, that's like a 2x45 chamfer. We'll stick some of them on. Apply that. Apply that. Apply that. So you put some nice chamfers on there. And the whole idea of this is you can work backwards. You can actually go back, and if you click on this the sketch icon there, and this eyeball will take you so that you're looking down on this all the while. Always make sure that you're looking down on it, because you can get really, it can get really confusing if you don't do that right. So what I'm going to do, I'm going to just add a groove to this by if I go from there to there and to there, and then I can go to trimming. So I can say join, which is where you join a line. So I'm going to join that to that. Let's trim that nicely. Well, I'm going to go there and there, and that's got rid of them. And now I've got a groove. I want to dimension it because it's just again been done on the fly. So I'm going to go there to there, and I'm going to, that's 10mm, and then I can do, obviously I can do it as a depth from here. Let's now dimension the rest of it. Just want to dimension these lines here, there, and there. When you want to edit these dimensions, all we do is just double click it. So close that first, and then just double click on that dimension. Then you've got the choice to write a new value in there, and then just rebuild that. So there you have it. Yeah, so that, as I said, that brings you back to the actual drawing view, and it's that arrow is the rebuild. I think I skipped over that a bit quick there. So that arrow's the rebuild. And what you have to do then is just click done. And what it will do then is it just gives you a name, so just say OK to that. That's just saved your part, your EWS part, and it takes you through to Edgecam. And you just in Edgecam, just like you had a normal solid model in Edgecam, which you would then save. So now I'm going to produce the same part. This time I'm going to use part modeler. So I'm going to start by drawing a line. I'm going to draw a horizontal line and a vertical line. What I'm going to do is dimension those. This gives me a sort of sense of proportion, because otherwise you could be producing this part really tiny, or you could be producing it massive. But if you get some idea of the proportion of the thing by dimensioning these first two lines before you start, then you know that you're working to roughly the same size. So I've got these two lines which represent the outside of my shape, and then I'm just going to do a continuous line, this continuous sketch it's called, and produce the rest of the shape. So I'm doing that, coming down, producing my groove, producing this next diameter down to this final diameter. Should be able to just latch onto there and down there, and then effectively I'm going to add the constraints to that. So I'm going to do some vertical ones first. I'm going to lock that one in, which ends up at 35 there, 35. Then this one, this comes in at 20, and then I can start to put these lengths in. I can do this one here, which is going to be 40, this one which is going to be 30. You can change these afterwards, exactly the same thing, you just click on it. 10 there. Then the depth of that, which is switch here, this one, and we want that in at 3. And then what I'm going to do now is analyze that profile. Click this icon, analyze profile. Really useful tool, because it tells you if you've got more than one open profile, that means that you've got other shapes on the screen which you probably don't want. So that's always going to be 0 really, and then you're looking for a closed profile. If you've got an open profile, then it won't build. This is telling you if there's any intersections, which again is a bad thing. It means lines are crossing, which you don't want. Overlapping profiles, you might have lines underneath that you can't see. And this is showing you the number of coincident constraints, which shows that the parts all joined up. Coincident constraints are where things join together. And then it's also telling me that there's loads of things that's under constrained. And I need to sort that out, because you're looking for a fully constrained model. So what I'm going to do now is put some vertical constraints. Although these look vertical, all that's telling me is that there's already a vertical constraint. You will get that because Edgecam does automatic constraints. There's another one. So they're all vertical. These should all be horizontal. That's already done. That's already done. That's already done. That one and that one. Okay, so everything is constrained vertically and horizontally. So let's do another analyze profile, which tells us that we've still got 10 things that are not fully constrained. All that means is that although this is in itself all dimensioned, it's not fixed anywhere. Now that probably doesn't matter, but in theory it should be fixed somewhere because it's actually floating around the screen. So let's put it back where it was. So we can create these fixed constraints and then we can fix that line there, and we can fix that line there. So then when we check now, we've got nothing is under constraint. So it's a perfect situation, that is. That's the close profile close. So that is a fully constrained model. And the way to test a model is if you start trying to pull anything, it just won't go. So you can either twist things at angles or stretch them or whatever. If you can do that, then it isn't fully constrained. So now let's do a revolve, and we want to select axis. Needs to be line. The axis is a line. Click that line there, which then goes dotted like that. You can preview it if you want, but that looks great. I'm going to OK that. That's my shape. I'm going to stick some chamfers on it now. It's always a contention whether you want to draw these chamfers and rads at the drawing stage or you want to put them on at the end. But something that's worth noting is that when you start adding construction planes, if you want them to edges and you've got chamfers on, sometimes those construction planes just, it doesn't work out right, and you end up extracting geometry and things like that. So sometimes, well, I think that it's always a good idea to leave it right till the end to put all these chamfers and rads and things on. I'm going to use offset and angle, so I'm putting 2mm chamfers on at 45 degrees. I'm applying that, putting one there, I'll put one there, and I won't bother with the back. Okay, and that's my part. So all I need to do then is just save that part. So now we're going to move on into Edgecam. We can use either the EWS model, in which case we'd already be in Edgecam, or we can use this part modeler file. First thing it would do is ask us to save it, but if it's already saved then it won't. This is the Edgecam link, so it's going to take me straight through to Edgecam. It opens up Edgecam with this model in it. Should open in a turning session because it knows that this is a turn part, recognises it, puts the datum in the correct place. Select a material so that Edgecam can calculate your feeds and speeds for you, and then fit some stock. So we use the fit stock, and this is calculated what stock it thinks be suitable. There's a mil on the front face, 25 on the back face, and I'm going to make the diameter of the stock 125. So that's my bit of stock that I've ended up with. Automatically puts this on the stock layer. Then I'm going to create a machine. Machine I'm going to create is this sample lathe 2-axis millimeters. That looks like it'll be alright. And it places my part in the chuck. You can play around with these jaws and get them all the right size and everything. Can't be bothered at the moment, but it is something that I recommend that you do, because what you don't want to do is collide with your chuck jaws. That's one of the massive advantages of Edgecam, in that it can tell you if you're about to clobber these chuck jaws. So what we're going to do then is we're going to do a feature find. So we're going to find the features that we want to machine. So we want the turn profiles, the front face profiles, we don't want the back, we want grooves, we've got no threads, and we've got no bores, so we'll OK that. And it's come up with all these features, and having got those features, what we'll do then is we'll go in and we'll plan it. So we'll go to machine and we say plan. What it does then is it comes up with a plan. It's saying it's going to rough the front face, rough the front turn, rough the front groove, finish the front groove, finish the front face, finish turn. Sounds good to me. So I'm going to let it get on with it, and I'm going to say apply. When I say apply, it's now in the process of generating all the Edgecam information that we need. So beavering away and doing all that in the background. Rough turn, finish turn. Should do all the grooving and everything. And you'll see all these ticks when it's finally complete. I'm going to go into simulator now. Let's put this in a nice view. And let's see what we get. So it's facing it. Rough turn. Speed some of this up now. Any collisions, it'll glow red, it'll tell us that we've got a bit of a problem. So that's the roughing tool, and it's going to come in with the first grooving tool. Groove this out. Now it's coming in with the finish grooving tool, and it comes in with a finish turning tool, which it faces, turns, finish turns, away it goes. Job done. So now let's produce some CNC code. We just click the NC code and then click generate NC code. Work our way through these boxes. And then we get the code. And that looks really good. Obviously it's the time you spend on your post-processor that gets this exactly as you want it to be when it goes into your machine. And that would go into that CNC lathe and run perfectly.